Okay, so we're diving deep into the world of T cells today. Looks like you sent over some pretty in-depth notes on these little guys, so I think it's safe to say you're ready to go beyond the basics, huh?
Always excited to explore the immune system. T cells, yeah, they're a fascinating piece of that puzzle.
Right. I was looking at this immunology module, 3 Lymphocyte T by Dr. A. Buffertella, and it says that almost 70%, like nearly 70% of the lymphocytes in our blood are T cells. That's a huge part of our defenses.
Yeah, it really shows how important they are to what we call adaptive immunity, right? How we recover from things like, just a common cold or fight off those more serious infections. Even give us a fighting chance against cancer.
So they're kind of like this elite warrior force inside us, but where do they even come from? Where do these microscopic heroes start out?
Well, it all begins in the bone marrow. That's where T cell progenitors are born. These, we call them recruits, I guess. They're also known as CLPs and ELPs.
JLPs,
Right.
ELPs.
And these guys, they're guided by chemical signals to the thymus, which is like their training ground, or as Dr. Buffertella calls it, their microenvironment.
Microenvironment. That sounds intense, like some kind of boot camp, but on a cellular level.
Exactly. It really is like a training ground. Inside the thymus, these young T cells have to go through this, well, it's a rigorous selection process, like a talent show, but with incredibly high stakes.
And I see here in these notes, there's positive selection and negative selection. Those don't sound like any test I ever took in school. What are these T cells being tested on exactly?
Yeah, you're right. Not your typical exams. So imagine this. Positive selection, it's like making sure each T cell can actually, you know, see the enemy, so to speak.
Okay.
They have to show that they can recognize these things called MHC molecules, which are basically like billboards on cells that are signaling, hey, over here.
I see, I see.
And if a T cell can't spot those billboards, well, it's not going to be very effective at its job.
But you can't exactly fight what you can't see.
Exactly. And then there's negative selection, which is even more, I guess you could say, intense. This stage is all about weeding out any T cells that might mistake the body's own cells for, for invaders.
Ah, so it's like preventing friendly fire, making sure they don't attack the wrong cells.
Exactly. Absolutely crucial. It's called self-tolerance. This is how we make sure T cells only target actual threats and not the body itself. And it's a really precise process. Believe it or not, only about 5% of these T cells, they actually survive all of this rigorous training to become fully functional, mature T cells.
Wow, 5%. That's a tougher acceptance rate than anywhere I know. No wonder they're considered such a powerful force. But what kind of weapons are we talking about here? What do they use to fight?
Their main weapon is called the TCR, or the T cell receptor.
So the TCR is kind of like what, a sensor? It helps them find those MHC molecules, the billboards we were talking about?
It's actually even more specific. The
Hmm.
TCR is designed to pick out these things called antigens. Think of them like unique fingerprints, but on bacteria or viruses, even on our own cells when they're not acting quite right.
Oh, okay, so it's not just about seeing the billboard, it's about reading the message on it, the antigen.
Exactly. Each TCR is made to recognize a very specific antigen, almost like a lock and key. And when that TCR finds its match, well, that's when things get interesting. But it doesn't act alone. There's another piece to this puzzle, something called CD3.
CD for...
Yeah, CD3. It's crucial for what Dr. Buffertella calls signal transduction.
Okay, now that sounds complicated. Signal transduction, what's that mean in this context?
Basically, think of CD3 as the walkie-talkie. So the TCR, it grabs onto the enemy, right, recognizes it, and then CD3, it sends out the alert. It relays the message to the inside of the T cell. That then triggers, the next phase of the immune response. It's all about communication, making sure everything works together.
Wow, so there's a whole lot of communication going on at that microscopic level. That's amazing. Now, this module also mentions CD4 and CD8 T cells. Are these like specialized units within the T cells, different branches of the military, maybe?
That's a great analogy. You can think of CD4 T cells as the brains of the operation, the strategists, if you will. They're often called helper T cells because their main job is to direct and coordinate the entire immune response. They release these chemical messengers called cytokines, which are kind of like rallying cries, bringing in reinforcements from other parts of the immune system.
So the CD4 cells are like the generals, they're directing the fight. What about the CD8 cells then? Those sound more like the frontline fighters to me.
You got it. The CD8 T cells, they're the heavy hitters. We call them cytotoxic T cells. These are the ones that directly engage with those infected cells or cancerous cells and take them out very precisely.
Direct engagement. So they're not messing around with signals. They're getting their hands dirty.
Precisely. And even within those CD4 helper T cells, there's even more specialization. Dr. Bufertel uses a good analogy in the module, actually. He compares Th1 cells, which are a type of CD4 cell, to, get this, internal affairs.
Internal affairs.
Yeah.
Yeah.
Because they're focused on threats that are inside of our own cells, like viruses. And then there are Th2 cells, which are more like experts in those external threats. They're the ones that activate B cells, which are responsible for producing antibodies.
This is incredible. It's like we have scouts, strategists, assassins, even like a whole weapons manufacturing division all going on in our bodies. But how does it all get triggered? What tells these T cells to spring into action? So we've got all these different types of T cells, right? Like the scouts, the generals, the assassins, but how do they know when to actually use all of that? What actually activates them?
It's kind of like a three-step security system. It's not enough to just like see someone suspicious. You need a few confirmations before you actually do anything. Dr. Bufertella, he calls this the three-signal activation process for T cells.
Three-signal activation. Okay, that sounds pretty thorough. What's the reasoning behind that?
Yeah. Well, you got to remember, T cells are powerful, right? We've been talking about all the things they can do, so you don't want them going off all willy-nilly, The first signal, that's the initial recognition, where the TCR, it locks onto its antigen, like we were talking about before. But that alone, that's not enough to, like, pull the triggers like, I don't know, getting an intel report. You need more to go on than that, right?
Right. So what's the second signal? What actually confirms that there's a real threat?
So the second signal, that's called co-stimulation. Basically, it's like a handshake between molecules on the T cell and molecules on the cell that's presenting the antigen. It's like getting the green light, from headquarters. It gets a little, I guess, technical here with all these different molecules like CD28 and CD80.
Yeah, I'm seeing those here.
But the main idea is the T cell is getting confirmation from these other immune cells that, yeah, this threat is real. Time to get ready for action.
Wow, it's amazing how much communication is happening at such a tiny scale. And there's a third signal. What's the final trigger then?
Think of the third signal as the launch codes. This usually involves those chemical messengers we talked about earlier, cytokines, IL-2, that's a big one here. When IL-2, it binds to its receptor on the T cell, that's it. Orders are given. Go, go, go.
Wow, so three signals. Recognition, confirmation, authorization. That's a pretty amazing system. But when those CD8 cells, the assassins, when they get the green light, how do they destroy the enemy? What's their weapon of choice?
Remember those granules we were talking about, those little sacs inside the cytotoxic T cells? Yeah. They're full of these really powerful proteins, like perforin and granzyme.
Perforin, granzyme.
Yeah, so Dr. Bufertella, he describes perforin as basically punching holes in the infected cell's membrane, like a tiny needle.
Ouch, that can't be good.
It's not. And once those holes are punched, that's when granzyme steps in. That triggers this process called apoptosis inside the infected cell.
Apoptosis, isn't that?
It's programmed cell death, basically. It's a way for the cell to self-destruct without, causing a whole big mess, without damaging other cells around it.
So it's like a clean getaway.
Exactly. Precise and controlled.
That's incredible. I mean, honestly, the complexity, the way everything is so coordinated, it's mind-blowing. We started with T-cell bootcamp, and now we're talking about targeted assassinations at a microscopic level. And it's all happening inside us right now.
It really is incredible when you think about it. And you know what? We've only scratched the surface here. There is so much more to learn about T cells and, honestly, how important they are to keeping us healthy.
Well, I know I have a whole new appreciation for what's going on inside my body now. And I think anyone listening, they probably feel the same way. I have to say, though, thinking about how all of this works, it does make you wonder about those times when things go wrong, right? When the immune system doesn't quite work the way it should. I guess that's something to think about. Thanks for joining us on this incredible journey into the world of T cells, and until next time, keep exploring.